before going to prove the validity of an argument using inference theory, first of all, we know what is the definition of inference. Inference is nothing but the process of deriving conclusion using logical reasoning. I am repeating, inference is nothing but the process of deriving the conclusion using the logical reasoning. This is called the inference, right? So here we are saying that logical reasoning, that means there are some rules. So those rules are called inference rules. So we use these inference rules to prove the argument is valid. That means we are given some premises. So using those premises we arrive to a conclusion. So here we assume that all the premises are true. If all the premises are true, then conclusion is also true. Then that means the premises, the conjunction of the premises implies conclusion is a tautology. So when the conjunction of the premises implies conclusion is a tautology, then only the argument is said to be valid. Clear? So we prove this by using inference method. That means we use some rules, inference rules. So we need to know some inference rules. First rule is addition rule, right? Addition, we call it as addition. What is addition rule? All we know that addition is nothing but sum. Sum is nothing but R symbol. That means if we take P, okay, P. So if P is true, we assume that in inference theory all the premises are true. If all the premises are true, then it leads to a true conclusion. So if it is a true conclusion, then argument is the valid. Okay. So we need to remember, we need to keep this point in our mind, right? So if I take P as a premise, we are given that P as a premise. If P is a premise, that means P is true. If P is true, we can write it as, the conclusion is, if P is true, P or Q is also true. Clearly we know it, isn't it? If P is true, P or Q is also true. This law is called addition rule. This is called addition rule. Okay? P is true, then P or Q. That means P implies P or Q. Similarly, if Q is true, that also implies P or Q. So if P is true, then it implies to the conclusion P or Q, or Q is true, it implies to the conclusion P or Q. Okay? Then simplification rule. Simplification rule. What is simplification rule? P or Q. P or Q is the premise and which is true. Then we can say that if end, here not R, end, P and Q, simplification is nothing but end, connected with end symbol. P and Q is true. So if end is true, when end is true? Yes, end means both are true, then only the result is true. That means P is true, Q is true. P and Q, both values are true. That means you can write it as P as well as Q. So the conclusion arrived to P or Q. Clear? So if P and Q is true, then we can say that P or Q. P and Q implies P or Q, right? Okay, this is called simplification rule. Okay, next the other rule is conjunction rule. Conjunction means if P and Q both are true, P and Q both are true, then that means P is true, Q is true. P is true, Q is true, then P and Q is true. Okay, so if both are true, then the end symbol is true. Clear? So for R connective, at least one is true, it is enough. But for end connective, end is very strict. All we have discussed it in the class. Okay, end is very strict. That means if both are true, then only the result is true. At least one is false, then the result is false. So if P and Q both are true, P is true as a premise, Q is a premise which is true, then the conclusion is P and Q is also true. Okay, this is called conjunction rule. Conjunction rule. Next rule is modus ponens. The rule is very new. The name is somewhat different, but the rule is very simple. Modus ponens. The rule name is modus ponens. So modus ponens tells us if P implies Q is true, P implies Q is true, and P is true. P is true. P implies Q is true. P is true. Then what is true? Okay, can you say? Right, Q. The conclusion is Q. So if we say that P implies Q is true, that means if I take P is also true here. If P is true, then P implies Q has to be true. Then P should be taken as true. If P we are taking true, Q should be true only, because we are connecting the implies rule. If P is true, Q is true, then only implies connectivity is true, otherwise false. Therefore, okay, we all know the implies rule, right? So P implies Q is true when P is true, Q is also true. If P is true, Q is false, then it is false. Therefore, we assumed that P is true. That means to have P implies Q is true. So P is true, then Q is also true. So which is called modus ponens rule. Next, modus tollens. Modus tollens. Modus tollens rule is similar to modus ponens. That is, P implies Q is true, and we are taking here negation Q is true. Negation Q is true. P implies Q is true. Negation Q is true. Then which is what is our conclusion? Yes, negation P. Okay, we are saying that negation Q is true. That means Q is false. Clear? We are saying that negation Q is true. That means what about Q? Q is false. So if Q is false, then P has to be false, because P implies Q true when both first value is false, then second value is false or true. Don't bother about the second value if first value is false. But here already we know that second value is false. Whenever second value is false, if first value is true, the result is false. Therefore, we need to take first value as false. Therefore, false implies false is equals to true for the implies connectivity. Is it clear? Therefore, negation Q is true according to our assumption. Therefore, P is false. Then what is true? Negation P is true. Negation P is true. So which is our conclusion. So there are some more rules, but before going to discuss those rules, we will discuss one problem, right? So these are the basic rules which are frequently asked, we frequently use to prove the validity of the argument. So before going to prove the validity of argument, or before going to do the problem, we should know one thing here. By using inference rule to prove the argument, we need to remember 2 points. There are 2 basic rules. Those are called rule P, rule T. Rule P, rule P and rule T. What is meant by rule P? Rule P. Rule P is nothing but we may introduce, rule P is nothing but we may introduce any premise at any stage of derivation. Isn't it? We can introduce any premise at any stage of the derivation. Okay? And rule T is nothing but we need to form a formula. Okay? We generate a formula using the premises which we used previously. Okay? So our logical equivalence. We also can use the logical equivalence, laws of logic, and previous premises. Using those three, we can generate a formula which is a true formula. This is called rule T. That's why it is called rule T. That means rule P is nothing but introducing the premise. Remember that rule P is nothing but introducing premise. Rule T is nothing but generate a formula using the premises. Generate the formula. Clear? Okay. So we need to keep these 2 points in our memory. Clear? Now we do this problem. Now observe this problem. What is the problem here? Demonstrate that R is a valid inference from the premises. From the means these are the premises. P implies Q, Q implies R and P. Okay. So first of all we need to identify what are the premises and what is the conclusion. Right. So clearly R is the valid inference from the premises. That means R is the conclusion. Here R is the conclusion and there is 3 are premises. So how many premises are given here? Premises. First we need to write the premises. So premises are P implies Q, one premise, Q implies R and P. These are the premises. And conclusion. What is the conclusion? R. So we need to use these premises to reach our conclusion, right? So what is the rules? What are the basic rules? We can introduce a premise at any stage of the derivation. Okay, so first start with introducing a premise. So what is the first premise I am taking? So you can take any premise, not the first premise. So according to our convenience, we can take any premise, either first or second or third. It is depends upon us. Okay. So first I am taking P implies Q. P implies Q. I am taking this premise. Okay. And that means if I take this, that means introducing the premise. I introduced premise P implies Q. So if I introduce the premise, it is called rule P. Okay. So there is no formula for this. That's why I am again introducing one more premise. So I am introducing the premise. That means if I introduce the premise, I take curly brackets and write 1. That means it indicates that I introduced the one premise. Right? Whatever it may be, first or second or third, it doesn't bother about the order of the premise. So 1, but here in this case I have taken first premise, right? So P implies Q. Now I have taken the second, introducing the second premise. What is the second premise here? Q implies R. Or I can also take the third premise also. So let me take the third premise. So here I am taking the third premise. What is the third premise? P. Okay. Here also I introduced the premise. We call it as rule P. Now observe that P implies Q, P. What is this rule? Just now I have discussed one rule. What is this? Modus ponens, right? Modus ponens. So if first value is same in these two, P implies Q and P, then what we get? Q. We get it as Q. Clear? Q. Right? So P implies Q, P. That means P implies Q, P is nothing but we can say it as P implies Q. We can write it as negation P R Q. Always we use conjunctions between these premises. Conjunctions between these premises will give the conclusion. Okay. So negation P R Q and P. So here clearly negation P and P get cancelled. Negation P and P get cancelled because negation P and P is false. False or Q is always Q. True, right? Q. Clear? So we got Q. So what we use here, this is the formula we generated. So this is the formula. So using 1 and 2 we got a formula. Using 1 and 2 we got a formula. So we generated a formula. So we use rule T. This is rule T. Clear? Now I am introducing one more premise. What is the premise remaining? Q implies R. So I am introducing Q implies R now. Q implies R. So I introduced one premise, two premises, and now I introducing third premise. Third premise. Or 1, 2, 3. This is also premise. So I am introducing fourth premise. Fourth premise. So Q implies R. Q implies R. If you observe these two values, Q implies R. Same again we used the modus. Right. Modus ponens rule. Q implies R, Q. Q implies R, Q. Q implies R, Q, which gives us R. Right, exactly. Q implies R and Q, which gives us R. So here we used rule P, and here we used rule T. Rule T. So we generated a formula. Here it is modus ponens. So P implies QP, modus ponens, we got Q, and Q implies R and Q implies R, Q implies R. That means Q implies R and Q. That we got it as R. It is also modus ponens. So what is the conclusion we need to get? R only. Clear? So that means R is a valid inference from the given premises. So like this we do the problems of this kind, inference rules. Okay. So if possible we will discuss more problems in the next session. Thank you.